So as you know, in last class, we derived the derivations for kinetic energy of a rotating body and as well as work done by torque. So what is the formula for kinetic energy of a rotating body, everybody? So if you take normally, what is the kinetic energy formula? Half into mv square. So if you take the body which is in rotation, so what is the kinetic energy formula, everybody? Half into, so mass will turn up into moment of inertia and v will turn up into angular velocity square. So this is what's the derivation also we have made in the last class. Am I right, everybody? So angular momentum, sorry, when the body is in rotating motion, so kinetic energy formula is half into I into omega square. So for this derivation proof also I have taught you. Am I right for those? Correct? So now if you have taken same way, work done by the torque, when the body is in rotational motion, what is the work done by torque? So if you have taken, so what is the formula? Work done by the formula. Normally work done formula is what? Integral F into ds. Is there anybody in meeting or not? So now if you take, if the body is in rotation, so work done W is equals to integral. So force become torque tau and ds become d theta, angular displacement. So this is what is the proof. So with the help of these two, now we are going to study what we have studied, the work and energy chapter, work energy and power chapter, work energy theorem, kinetic change. So that is what change in kinetic energy. So that is all we are going to study in our today's class. So kinetic energy formula when the body is in rotating motion, half I omega square. So this omega means what? Everybody, angular velocity. And work done by the torque is equals to integral tau d theta. So these are the two formulas which you have remember and along with the proofs also. So now, based upon this, let us solve the first question. So all of you observe very carefully. So I am taking a two wheels, which is has been separated by a distance L. So I'm taking a two wheels. All of you observe. This is a wheel number 1, and this is the wheel number 2. Okay. So two wheels are there. So both has been separated by a distance L actually. Imagine like axis. So this is the two wheels I have taken. So both mass is same. Question number 1, you write it. So mass of this wheel is m and mass of this wheel is also m. Both has been separated by a distance L. Has been separated by a distance L. And axis of rotation, imagine, axis of rotation is passing exactly at the middle and the body is rotating like this. Imagine like it is a two-dimensional. So like this, the body is keep on rotating like this. So these are the two wheels. So now they are asking, what is the kinetic energy of the system, not the particular particle. So kinetic energy of the system, we have to calculate it. So that is what is our question. So now imagine this L. So and also having a wheel radius R, where this distance between them L is much greater than this radius. So this is what is the question. So we have to calculate the kinetic energy of this entire system. So what is the kinetic energy of the entire system if it is a body is revolving? What is the kinetic energy formula? Everybody? Yes, please. What is the kinetic energy formula? Everyone? Please respond. So kinetic energy formula K is equals to half into I into
I omega square.
Omega square.
I omega square. So that is the formula. So now, if you observe very carefully, all of you, so let us see what is the moment of inertia. So now, axis of rotation is passing. So now from this point, this total distance is L. Then what about this point, everybody? From here to middle point, it is 0. So 0 means here this distance is what? L by 2. And this distance is also which is equals to L by 2. So what is the momentum? Anybody? Momentum is equals to momentum of total system. Please respond. Momentum of total system is what? M into this body first. M into how much is the R? MR square, correct? So I is equals to M into R square. So now two bodies are there in the entire system. So what is the first body momentum? M into L by 2 whole square plus this body M into L by 2 whole square. So that is the total momentum. So now 2 times of this one. So M into L by 2 whole square plus M into L by 2 whole square, which is equals to 2 times of ML square or L by 2 whole square, you can take. So which is equals to 2 into M into L square by 2 square means what, guys? 4. So 2 ones are 2 twos are. So what is the total momentum? ML square by ML square by 2. So that's all it is. So now you can substitute in the formula. So kinetic energy is equals to half into, so we all know that formula I omega square. So I omega square. So half into what is the I value? Everybody? ML square by 2
Omega square.
into omega square. So 1 by 2 into 1 by 2 will become what? Everybody? 1 by 4 ml square omega square. So this is the kinetic energy of the entire system. So please solve. I hope everybody understand. So this is how you need to calculate the kinetic energy of the entire body. Do it. Nothing is there. Two wheels has been separated by a distance L, they are saying, and the distance between them is L, so which is actually greater than, more bigger than their radius R. So that is what we have to do it. Okay, you understand, everybody? Mr. Sai Karthik, for those solving up,
Yes, sir.
do it. Anything doubt, you can ask me. Call to that Rudreswar, what happened? Rohit, Rudreswar, Manya and Samaya. Okay, clear, everybody? Understood? Next.
Yes, sir.
Yeah. So next question is similar to what we have studied actually already. So just to take the next question. So we all people knows square lamina. So just you take a square lamina. Okay. So square lamina, you can see that. So what do you mean by square lamina? Basically, square means what? All the sides are what? Everyone. All the sides are
Equal.
okay.
Equal.
Axis of rotation is passing here. So diagonally, axis of rotation is passing through diagonal. So diagonal it is passing means you can see it is making the square into two triangles. Am I right or wrong, everybody? Yes, please.
Yes, sir.
Yeah. So axis of rotation, imagine like this. About this, completely the lamina is revolving. So now entire square lamina is revolving around about this axis of rotation. So I'm making into dash line. So that this is what is our axis of rotation. So now all of you observe. So the body is revolving with this, like about this axis. So now, so square lamina, where each side of a square is 10 centimeter. Are you clear, everybody? So 10 centimeter means how many meter? Everybody. 10 into 1 by 100 meters, which is equals to what? 10 by 100 meters. Okay, wow. Please respond, guys.
0.1.
Yeah, you can take for this, no issues. Okay, so that is what. And whose mass m is equals to 2 kg, and where tau is equals to 0.1 Newton meter. So this is what it is. Now we have to find the kinetic energy of lamina, kinetic energy of lamina after 5 seconds. After 5 seconds means what is the initially? Before starting, initially it is 0 only. Am I right or wrong? Everybody?
Yes.
So that is what. So they are asking, find the kinetic energy of lamina after 5 seconds. So option C is 25 joules. Option B, 50 joules. Option C, 25 joules. Option D, 100 joules. So this is the concept. Mr. Narayan, is solving? So this is what is about question. So now we want to find it. So I know you people cannot solve, but let me teach you. So you all observe and you will learn, think over it. That's all. So now as it is a square lamina, so that the axis of rotation is passing through the diagonal. So it is separating the rectangular lamina into two triangles. So this is one triangle and this is another triangle. So now what is the total mass of this, everybody? 2 kg. So means in the sense of what? This triangle will become 1 kg and this triangle will become what? Everybody?
1 kg.
1 kg. So now I will take this diagonal, whatever it is. You can cut any side, whatever the side. If you cut it, it will making into how many triangles? It is cutting into 2 triangles. Clear, everybody? So I can take one triangle where axis of rotation is passing through the base. You can take it. So we all studied already. So if I have taken the triangle, so imagine the axis of rotation is passing through the base. I will take it. So what is the moment of inertia, everybody? So one triangle, two triangles we have. So one triangle, and what is the height of the triangle? We all studied that. Let me take the height of the triangle is h now. So what is the moment of inertia of the about base, everybody? Moment of inertia about a base of a triangle. I already taught you people. Check your notebook and tell me. Everybody. Yes, please. Moment of inertia for those. Yes, you can take it about this point, and about this point. What is the moment of inertia? Everybody. Moment of inertia about a base, which is equals to what? Everybody? mh square by 6. Check your notebooks. You have solved. So mh square by 6 actually. So it is actually for one triangle I am writing. You can write two triangles. And what is the height of the triangle, everybody? Height of the triangle formula. Height of the triangle h is equals to, everyone. Height of the triangle h is equals to a root 2 by root 2. A root 2 by 2. So that is only a formula. Am I right? So which is equals to, I can say a divided by root 2. Because I will multiply both numerator and denominator with the root 2. So that it will become 2 will get cancelled, a by root 2. So that is the height of the triangle. So now you can see, if you substitute h is equals to that, so that is only for moment of inertia about base for one triangle. So totally we have two triangles here. So one triangle if I take it, so m into, so what is the one triangle mass, everybody? Two triangles, total square is 2 kg. So what is the mass of the one triangle, everybody? One triangle, what is the mass? All of you?
1
1 kg.
1 kg.
1 kg and h is equals to a by root 2. So that's all, substitute in this, you'll get it. So moment of inertia of a one triangle about a base is equals to 1 into h square. H value how much? A by root 2 whole square into 1 by 6. I'm writing separately. So what is the A value, everybody? A value how much? All of you. A value how much? I will write as this one as A square into 1 by root 2 whole square into 1 by 6. So what is the A value? Please respond. A value how much? 10 by 100 whole square into this one will become 1 by root 2 whole square into 1 by 6. So I is equals to 1 into 10 by 100 into 10 by 100 because whole square. This will become 1 by 2 into 1 by 6. So that's all it is. So now you can get the cancel. So what is the moment of inertia? So 0, 0 will get cancelled, 0, 0 will get cancelled. So what is remaining? Everybody. This is for moment of inertia for one triangle. So totally how many triangles we have? Everybody. We have how many triangles? Total two triangles. So total moment of inertia is equals to 2 times of this triangle of 1. So that is what 2 times of 1 into 1 by 10 into 1 by 10 into 1 by 2 into 1 by 6. So that is the total momentum. So 2 will get cancelled. So what is remaining? 1 divided by 10 into 10, 100, 100 into 6. How much, guys? Everybody? 600. So that is the total momentum. So please remember, moment of inertia of a triangle. Moment of inertia of a triangle about its base. So I is equals to mh square by 6. So that is the formula which you have to remember. So I am separating this square lamina into two triangles. So about the base, I am taking what is the moment of inertia, and I am making into double. Two moment of inertia, like two triangles is there. So the two triangles moment of inertia will become 1 by 600. So now we know they are asking what is the kinetic energy. So what is the kinetic energy formula, everybody? What is the kinetic energy formula? All of you. Half I omega square. So half into I value I got it 600. But what about omega? So body is at initial what is the time they have given? All of you check it. After how many seconds? All of you? After 5 seconds. 5 seconds means body initial angular momentum. Sorry, angular velocity. What is the initial angular velocity? Everybody? Body is in rest. Initially body is in rest means initial angular velocity is what? Everyone? And what is the final angular velocity? That is only we want it now. So you can see, so final angular velocity. So what is the formula? Alpha is equals to in a final angular velocity minus initial angular velocity divided by time period. That is only the formula. Am I right or wrong, everybody? Please respond. So final angular velocity is equals to alpha t minus initial angular velocity. So we all knows that initial angular velocity is already 0. But what about the alpha? Time value also I know. Time value how much, guys? What is the time value? T is equals to how much? T is equals to how much? Yes, please. 5 after 5 seconds. But what about the alpha? So alpha means angular acceleration. So that is only now. So how to find angular acceleration? We all knows that tau is equals to what is the formula? Tau is equals to what is the formula? I alpha. So tau value they have given. What is the tau value? 0.1. And I value we have calculated 1 by 600 into alpha. So alpha is equals to what? 0.1 into 600. So what is alpha? Please respond. Alpha is equals to how much? 60. Clear? So that is. So what is the final angular velocity, everybody? 6 5s are. Please respond.
30.
30 not. Say 300. 300 radians per second. So that is what is the final angular velocity. 300. 6 5s are 30, 300. So that is what you have to do it. 300 whole square. So which is equals to 1 by 2 into 1 by 600 into 300 into 300. So 2 ones are 2 150s are. Next 0 0 will get cancelled. 2 ones are 2 3 ones are 3 twos are 2 ones are 275s. So what is the kinetic energy, everybody? Kinetic energy is equals to 75 joules. So that's all it is. So once again I'm saying, so they have given a square lamina where the axis of rotation is passing through the diagonal. So if it is passing through the diagonal, it will split the square lamina into two equal triangles. Two equal triangles. So now about this point, the axis of we all knows that moment of inertia of a triangle when axis of rotation is passing through the base. So mh square by 6 and h is equals to what? A by root 2. So by substituting that formula, I will get moment of inertia of a one triangle, but we have a two triangles. So I will find the total momentum of a two triangles. That is what 1 by 600 I will get it. So then with the help of given data, I found the angular velocity. And then if I substitute in the kinetic energy formula, I will get it 75 joules. That is how we have to solve this question. So these questions are also very, very important. So I hope you all understand, everybody. Please solve it. Once it is over, you tell me. So Prados, clear? Narayan? Ready? So please solve it. Any doubt anybody can ask me, or else you solve. Completed?
Yes, sir.
Do it now. So next question. Next question, right? A wheel whose moment of inertia is a wheel whose moment of inertia is equals to 3 kg meter square and tau is equals to 6 Newton meter. Find the work done. Find the work done. Now I am going to introduce in this concept work energy theorem. So you have to be very careful. So find the work done by torque. Work done by the torque in 20 seconds. So which is actually starting from rest. Starting from rest. So that is what it is. So options. Option A 2400. Option B 3000 joules. Option C 3600 joules. Option D 1800 joules. So this is the options. So let us see how it will be happens. So everybody. Yes. They are asking, they have given a wheel whose momentum is 3 kg meter square and torque is 6 Newton meter. Find the work done by the torque in 20 seconds where it is starting from rest. They are saying that. So you can notice it. So they are asking work done. So what is the work done formula? Work done is equals to integral tau d theta. Am I right or wrong, everybody? So
Yes.
tau value is given 6 d theta. So as we all know, 6 is constant. So integral d theta. So theta varies from where it where? Limits. Anybody? Theta 1 to theta 2. So integration of dx. What is the formula? Integration of dx. X. Correct or not?
Yes.
So equals to 6 into theta, which will varies from theta 1 to theta 2. So that is what you have to do it. Now we want to find the limit. That is only is our target. So limits we have to find. What is this theta 1, theta 2? As it is starting from rest, then what is the theta 1? Everybody? Starting from rest. Theta 1 is equals to what? All of you? 0.
0.
Now we all know if it is theta 1 is 0 means then angular velocity is also what? Everybody? 0.
0.
And what is the time is the time they have given? Time t is equals to how much they have given? 20 seconds.
20.
So after 20 seconds, what is the theta they are asking? That is only theta 2. And what is the alpha they have given? Angular acceleration. Angular acceleration, we can find it. Let us see how to find angular acceleration. How to find angular acceleration? We all know that tau is equals to I alpha. So now tau value how much? 6. Alpha I value how much? 3 into alpha. So alpha value how much, guys? Angular acceleration 6 by 3 equals to how much? Everybody?
2.
2. So that is how I have been done. So what is the formula for finding the final displacement? Everybody, you can see is that. So theta we have to find it. So what is that, everybody? S is equals to ut plus half at square. So modify it into things. That is what? Angular displacement. Here initial velocity. Here initial angular velocity into time plus half into alpha into t square. So initial angular velocity is 0. So that whole term will become 0. So now theta is equals to half into alpha value 2 into time t square 20 square. So which is equals to 2 will get cancelled, 20 square. Theta is equals to how much, guys? Everybody? 400 radians. That's all. So we got it. Theta 1 is 0 and theta 2 is how much? Everybody? 400.
400.
So you can substitute it. Integral, that is what? Integral theta 1 to theta 2. So which is equals to 6 into theta into, so 0 to 400. If I substitute it, 400 minus 0, which is equals to 600 into 400, which is equals to what, everybody? 2400 joules. 2400 joules. So that is the answer. But you can see. So does we can solve like this? This is what I'm asking. So is it always true? If you solve like this is not true always, which we already studied in work energy. The work energy and power chapter. So always we have to use if you want to calculate the work done, we have to use some theorem. That is the theorem which is 100% always valid. What is the theorem, everybody? Of course, you got the answer 2400, but every time you may not get the same correct answer. So what is the theorem? We have to use it. You cannot calculate the work done directly like this. You have to use always a theorem which is 100% always valid. What is the theorem, everybody? That is only we can call it as work energy theorem. So you cannot solve this question like this way. We have to use, you must solve this question by using a what, everybody? Work energy theorem. Understanding? So ordinary way, you cannot use this one. So use work energy theorem and you can solve. So can you tell me what is the work energy theorem, everybody? Which you have already studied. Work energy theorem, please. Work energy theorem, I want it. Work energy theorem. What is that? Work done by all the forces. Work done by all the forces, which is equals to what? Everybody. Change in kinetic energy. So that is only called as work energy theorem. Am I right, Pradosh? So what is change in kinetic energy? Change in kinetic energy means what? Final kinetic energy minus initial kinetic energy. So that is only we need. So this is what we have to solve it. So what is the initial body is at rest? So that what is the initial kinetic energy? Everybody, what is the initial kinetic energy? Respond, 0. Because
0.
initially angular velocity is 0. and alpha value I got it 2, and time is equals to how many seconds? Everybody, 20 seconds. So now we want final angular velocity. So now you can see final angular velocity, we can find v is equals to u plus at. So I'll apply final angular velocity is equals to initial angular velocity plus alpha into t. So initial angular velocity is 0. So final angular velocity alpha value 2 and time is 20. So which is equals to how many? Final velocity. Everybody, angular velocity. Please respond. 40 radians per second. Understand, brothers? So initial kinetic energy is 0. So we want final kinetic energy. So what is the final kinetic energy? Kinetic energy formula, tell me. Half, everybody, half into I into omega f square. Because that is only kinetic energy formula. Am I right or wrong? Half into I omega square. Yes or no, guys? Now final it is. Final means half into I into omega f square. So that's all. So half into, what is the I value? Book they have given I value how much question? 3 into final kinetic energy, final angular velocity 40 square. So 1 by 2 into 3 into 40 into 40. So 2 ones are 2 20s are. So 2 threes are 6, 60, 6 fours are 24. So 2400 joules. So this is what is the final kinetic energy. So what is the work done by all the forces, everybody? Work done by all the forces equals to final kinetic energy minus initial kinetic energy. So final kinetic energy 2400, initial kinetic energy is 0. So which is equals to, what is the final answer, everybody? 2400 joules. So that is what. Of course, both the cases, what is the difference? Or both the cases, you got the same answer. But this is the one which is always 100% valid. Understanding? So a theorem based upon the work energy theorem only, you always need to solve in the exam also. Work done by any kind of forces, it may be frictional forces or gravitational force, some other, that is what, conventional or unconventional forces, whatever it is, change in work done by all kind of forces, which is equals to change in kinetic energy of the system. So this is only the one which is always true. So that is why you have to always solve the question with the help of this one. Of course, we are going to prove it now. So if you are okay with this, then we will prove that also. Work energy theorem. Everybody, solve this one. Anything doubt? Ask. Are you clear, all of you?
Yes, sir.
Okay, so write it now. Next. So let us see the proof. Okay. So what is this work energy theorem? So related to this work done. So we all knows that what is the work energy theorem, everybody? Work done by all the forces. So let me take the proof now. So we all people knows work done by all the forces is equals to what, everybody? Work done by all the forces is equals to what? Change in kinetic. So means final kinetic energy minus initial kinetic energy. So now if you have taken, so we all knows that work done W is equals to, for rotational body. What is the formula, everybody? Work done is equals to what? Integral tau dt. Am I right or wrong? So what do you mean by tau? So we all knows that tau means what, brothers? I into alpha. So I'll replace tau with I into alpha. So I into alpha d theta. I into alpha d theta. Now we all people knows alpha equals to. Can you tell me alpha equals to what is that, everybody? Delta omega divided by delta t. That is what? D omega divided by d theta. Am I right or wrong? Change in velocity divided by time period only, alpha angular acceleration. Right or wrong, guys? Everybody? Yes, please. That is what. So I will write integral alpha. I will replace with the what? Alpha I will replace with the dw by d theta into d theta. Now d theta divided by dt, which is equals to something. Anybody can tell me? Change in angular displacement divided by time, which is equals to something. Fastly, everybody. Angular velocity. Correct or not? Respond, everybody. Angular velocity, right? So which is equals to I is system is remains constant. I is equals to W in place of d theta by dt is equals to W into dw. So integration of dw. So what is that varies from? Angular velocity varies from initial velocity to final velocity. So limits it is varies. So can you tell me everybody? Oh, sorry. What happened to this? 1 minute. Can you able to see the screen, everyone?
Yes, sir.
So now, integration of w d theta, what is that? I is remains constant. So integration of everybody, x dx. What is the formula? Integration of x dx, which is equals to x square by 2. Correct or not? Please respond. So same way, omega square by 2, where varies from initial angular velocity and final angular velocity. So that's all it is. So now you can substitute. So I into, so 1 by 2 final angular velocity. Final angular velocity divided by 2 minus initial angular square of initial angular velocity divided by 2. So if I do it, what will happen, everybody? I into 1 by 2, I will multiply it. 1 by 2 into I into final minus 1 by 2 into I into initial square. So what is this actually? Work done by all the forces. Work done by all the forces, which is equals to what, guys? Which is equals to final kinetic energy. Will you all agree with me, everybody? Yes, please. Minus. This all is equals to what? Initial kinetic energy. So that's all. So work done by all the forces is equals to final kinetic energy minus initial kinetic energy. So this is only we can say what? Change in kinetic energy. So that is how you have to prove it. Meeting is going to end, join back and we'll continue. Okay, everybody clear? So this is what? Work done by all the forces, kinetic energy. Change in kinetic energy is the verification. Proof. Very simple proof. So you can simply just replace tau and alpha